Good evening, all. So today, actually, I'm thinking of discussing about a topic which is related to grade 9 and grade 10, as well as grade 11. So since we didn't have the live class last day, I'm thinking of doing this as a recorded session. And the topic is about data representation. Please write the heading, this data representation. I have already released the Sinhala medium one, so that's why this note is there. But for the English medium students, please write the heading data representation. So what do you mean by representation? The presenting means you present something, you show something, right? So represent means you show something instead of something else. So let's say you have a seminar. Let's say you have a seminar and you are asked to participate the seminar, but due to some circumstance, you are unable to attend the seminar. Due to some circumstance, maybe you are not well and you cannot attend the seminar. So to represent you, on behalf of you, so they might tell that on behalf of you, your parent can come and sit and listen to the content. So then what really happens on behalf of you, instead of you, your parents is going there. That is called representation. The parent is representing you. The parent is representing you. That's called data. That's not data representation. That is called representation. That means instead of something, you tell, okay. So this data representation, why this is used in computers, we are using this 1 and 0 for representation data, representing data, and 1 can be there to indicate that presence of voltage, presence of voltage. 1 can be used to represent presence of voltage, and here the other hand, it is absence. 0 can be used to represent absence of current or voltage. Absence of current or voltage. So that is to represent absence. And so to tell that is on, something is on and something is off, again you can use data representation. And to say yes or present, and to tell absent, so data representation can be used, present and absent. And you can say yes or no, or high voltage or low voltage. Low voltage. So data representation can be used, or 0 volt, 5 voltage and 0 voltage. Or you can say representation can be used to show NS, or north based, north magnetism, north pointed magnetism. And the other hand, you can say south pointed magnetism. Anyway, two status. This is called two status logic. This is south pointed magnetism. So let's see how these things are used. And so it can be used to show pit and land. So this is why this north pointed magnetism is used, and that is how we store data in hard disk and floppy drives, or magnetic tapes or magnetic disks. And why pits and lands, that is how we store data in optical drives. Let's learn how this are done. Anyway, so in addition to that, you can say yes is 1 and no is 0. Anyway, two status can be represented by easily using this 1 and 0. Instead of telling voltage is there, you can say 1. Instead of telling yes, you can say 1. Instead of telling present, you can say 1. Instead of telling 5 voltage, you can tell 1. Instead of telling 0 voltage, 0. Or no voltage, 0. Off, 0. No, 0. Land, 0. South pointed, so So this can be interchanged, right? This can be interchanged. So again, then 5 voltage, if 5 voltage is 0, 0 voltage is 1. So you can interchange. Or if presence of voltage is 0 and absence is voltage of, anyway, 2 status are used to represent these things. So that is called representing data. So here you can see the on button, power on button of the computer, you can see 1 and 0. It represents 2 status are there. Either you can on or off. Right, I think now we have a clear idea about what data representation and why data representation is so important, because instead of telling long story, you can tell one thing, 1 or 0. It's easily represented, can be easily represented. So let's see how this is represented in magnetic disks. So if you go to Google, and here this is your power button, and if you Google how data stored in hard disk, so you can see how data stored in hard disk. You can see, so this kind of images. So there are many explanations like this, right? You can see this kind of explanation, but anyway, so simplest way to tell this, you can say, so 1 is represented using north south and 0 is represented using south north. So this magnetic head, actually read write head, is organizing this magnetism in the disk, or this kind of disk in your hard disk. So this is called basically the platter, and platter has magnetism. So platter has these kind of tracks. So here read write heads are there. So you have 4 platters and 8 heads, because it's reading writing both directions, the upside and downside both. Unlike CD, you don't have label in hard disk. So you can write in the top layer and the bottom layer, upside and or downside. So you have these kind of things. Basically, this is physically, you cannot see anything, right? This is logically, it's divided to these tracks. These are the tracks. And then the other direction, when you divide this direction, sectors. Inside sectors, and this is how it physically looks like. Right? This is rotating. I think you have seen cartoons like that, what do you call that, Borolugoda and Galpatha cartoon, the song that I cannot remember the name, Agiripura. So that cartoon you can see, what is that, Giripura. It has English name, I cannot remember the name, I'm just browsing English. So its name is, yeah, I think, yeah, this one. Flintstones. So Flintstones. And in the Flintstone cartoon, so you can see, I just want to remind you a small session there. A bird. Bird record player. So this is what I just want to remember, right? This bird record player, you can see. This is cartoon, but I'm just using this, right? So this bird record player. So basically, this platter is circulating, or this plate is circulating. So what will really happen? So bird is moving its mouth here and there. So so what will happen when it's moving? You can see it's reading and writing. That is imagination. Just make use of fun. And but anyway, so that is really good thing, because in gramophone also, I think you have the similar technology. Gramophone has the similar technology, right? So gramophone, you can say the animation. If you want to see the animated one, you can see. Right, you can see how it's read. So it's going, and this head is moving. Right, when head is moving, so what will happen? When head is moving, so this platter is circulating and it can read. So rather than searching for gramophones and Flintstones, all these things, you can just browse for how hard disk works in, there's a website called Animadra. drafts. And there, I think you can see how hard disk works. Should be there in this. Yes, here. This is animation-based website. You can just browse over there and you can see, right, these are the platters. And platters are rotating and read-write head is moving back and forth. So when it's moving back and forth, the data is written to the both sides of the platter. So that is what happened. And you can see the connector, logic board, and these platters, read-write head, spindle. Spindle is the one which rotating the hard disk actually. So there's a speed. So basically one speed is 7,000 revolution per minute or rounds per minute, 7,200 rounds per minute to 9,000 revolution per minute. So more speed, more writing, more data. So it can write more data. If my speed is high, it can write more data likewise. Okay, so anyway, now I think you have the idea, right? You have the idea how this happens, and you can further explore this, right? So in the Anima draft, you can just go down. So just note the URL, right? You can just go down and see how these are working. And this is your read-write head, which is writing to all the platters. And speed is here, 50. So 50 movements per second. So that is high speed, right? So not just that, you can see here, right? This is most important thing. When it's moving, what will happen? The magnetism, you can see here, there's one magnetism this side, another magnetism. This magnetism is actually in the platter surface. So what will happen? So by the head, it will change the platter surface by magnetizing the. So I think now you can understand this very well and how this happened. And these are the heads. So right, this is the structure of spindle, but these are not needed for your level, but you can further study down and you can analyze what will happen and how circulation happen, what is the logic board and what kind of, you can see, right? This is how it's rotating and writing and reading data. Right, so I think now you have more clear idea about how this happens in the hard disk. So anyway, the two status are this south, north, and north, south status. So this is how data representation happens in your hard disk. So let's check with the Anima drafts. Has the Anima drafts, yes, how CD works. I have never browsed that. How CD works. This page is heavy, right? It might slow down your computer. Anima drafts, no. How CD works. No, it's not there. The hard disk work, it's there. But how CD works, it's not there. Right, but anyway, you can just search using your friend, that is Google. Just Google it. Right, okay. So now you can see how CD works in these images. So in CD, there are multiple layers, right? In CD, there are multiple layers. So let's think about one thing, so rather than just analyzing all these things together. In CD, you have label, and then you have aluminum layer, and in the middle, and then you have polycarbonate layer, which is transparent one, and also acrylic layer, and so the responsibilities of each layer's label is just indicating, and this is a protection layer in between that. So, and then the aluminum layer, that is where you write the data, and polycarbonate layer, plastic layer is a transparent layer. And what will happen in the CD, right? What will happen in the CD? So this when you want to write data to the CD, and there's a laser light pointing, and it can travel to this transparent polycarbonate layer and access the layer in the middle. It can access the layer in the middle, right? So you don't need this much of detail, but just write how, just understand how this happens. And so then when it accesses this layer, so assume that there's a laser bulb which is lighting up, and this lighting up or lighting laser bulb can burn the CD. So we usually call CD burning. No? The lighting laser bulb can burn the CD and create a pit. And the other hand, so when it is not lightened, so then it will not burn the area. You can see pits and lands. A lot of pits and lands are created in the CD in a circular manner. So similar to that hard disk, this is also rotating in the CD drive, and laser beam is burning the aluminum layer. Actually, some of the CDs, in addition to this aluminum, it has platinum or gold plated layer. But the thing is, now you can see mostly the aluminum layer. This can see sometimes, okay, so this in between layer, this yeah, it's not given here. So yes, compact is aluminum, platinum, or here. So these are the, so let's see image by image. Aluminum CD, compact disc. So you can see in a search. So this is the aluminum version, but there are some other, like this is gold, right? This is gold one. This is gold plated one, but it's rare, costly, rare. But this one is like more reliable than the aluminum one. And in addition to that, you have the platinum one also. Platinum. So that is basically blue color. So it has a blue color, the platinum one. It has a blue color, platinum, gold, aluminum. Just search in the YouTube, I think you can find all these things. You can see platinum. Yeah, these are the things. This showing the colors, but so you can see there are various versions. So mostly we use the aluminum version, right? Mostly we use the aluminum version of CD. Anyway, so what will happen basically when you burn the CD, this aluminum layer is melted. So how the reading happens then? Reading, how it happens? So reading is basically happens through reflecting of the lights. Reflection is used for reading. So let's see, let's go back. Right, you can see, okay, let's see this one. So when it hit a burn spot, okay, when it hit a burn spot, so the reflection will be different, and unburned spot, so it reflects. So one can tell the burn spot won't reflect, the unburned area might reflect. Or someone can say the reflection angle, right? Someone can tell about the reflection angle. So when there's a pit, the reflection angle is different, and when there's a land, reflection angle is different. That is another way. So anyway, so there are differences. Pit and land, two status differences are there. So it can be angle difference, or it can be reflection difference, or it can be absence of reflection or the presence of reflection. Anyway, so you have two status. So you will store two status and you will read two status. And now I think now you know very well how these things are stored in CDs and these magnetic disks and optical disks. So data representation is a very important topic when it comes to store values or store data in these and also how data travels as a signal. In wires, data travels as high voltages and low voltages, high voltage, low voltage way. Okay, I think the first part is done with that. Now you have clear idea about how data represented. Okay, then topic number 2. In topic number 2, we will study how images represent, how images are represented, how sounds are represented, and how characters are represented. Likewise, there are various things which we use in the computer, and we will study how each of these how each of these are represented inside the computer. That is our second focus. So let's learn about images in the first instance, and then let's move to the sound and other media. First learn about the images, and then we'll move to the other areas, right? Okay, carefully look at the image now. So when you look at the image, you can see, so this is image. Actually, this image is represented using pure ones and zeros, or pure binary, right? So let's take so portion of this image and magnify. So now you can see, so these dots, or the, images and this, so you have this in grade 11, right? But anyway, so this topic is common for grade 10, 11, as well as this is there in the previous grades. So that's why I'm sharing this for both grades now, right? 10 and 11. And you have the image processing, or this image editing software in grade 11. There you will learn this, right? So you got if you get this kind of image, if you zoom this, you can see so some numbers. So basically, if it is a binary image, you can see 1 and 0. 0 is like bulbs are off. 1 means bulbs are on. The on areas are shown in white color because bulbs are on. Off areas are shown in black color because bulbs are turned off. And actually, so let's see, this is the actual thing. But what happens when it has colors? Then these pixels are having, so not just single value, it has multiple values. So for an example, so if it has, like, let's say it has 8 colors. 8 colors means you need at least 3 bits to represent 8 colors. I think you can remember the basics of number systems. If you have 8 colors, these are the 8 colors. This is what color 1, color 2, color 3, color 4, color 5, color 6, color 7, and color 8. If you have 8 colors, these are the possible values that 8 colors can get. So then each one of these will have 3 bits. 3 bits. So then how it is represented? So you need another dimension. Basically, this is not single now. It has another 3 bits. So let's say this is a 3D, right? 3D, it's going up, coming toward our direction. So have you seen 3D LED grids? So this is 3D LED grid. So in 3D LED grid, so this third dimension means it's coming toward us. It's coming toward us. But 2D LED, it can represent only, if it is 3D LED system, it can represent so many more. So some other dimension. So, but actually when you take, so it doesn't have 3. So nowadays, normally 1 bit has 24 bit to represent the color. 1 bit has 24 bits. So 1 pixel has 24 bits. Imagine. So how many colors? Then you can write, if there are 24 bits, you can write 2 to the power 24 colors. 2 to the power 10 is 1000. 1024 to the power 20 is closer to 1 million. 2 to the power 21 is 2 million, 3 million. Then 2 to the power 1 million is 2 to the power 20. 2 to the power 21 is 2 million. 2 to the power 22 is 4 million. 2 to the power 23 Tree is 8 million and 2 to the power 24 means 16 million. So that number of colors can be represented. So because if there are 24 bits, you have number of ways to write the colors. And why this octal and hexadecimal are also there? Because you know, when you have like 24 bits, so this is so this is 24-bit color. Then, but you can shorten this by writing 3 by 3. That is where octal is used. If you use 3 by 3, you can make this short. This 3 and this 3 and this 3. So then you can write the number in octal as 001 77 4 00, and that is the octal representation. And the other hand, hexadecimal is even better than the octal. Why? Because you can write 4 by 4 and shorten this more. And then you can write, okay, so this is what? So 00 and it's FF 00 FF 00. So this is how you write in hexadecimal, right? Anyway, so what actually happens is it's not shown in decimal, octal, or binary. It's shown in hexadecimal because of this shortness of the code. So let's see how actual picture works, right? Let's see how actual picture works, and then you can realize this. So now we can see actual picture in my screen. So let me zoom this, right? Still you can see this as picture. Still you can see this as a picture. Let me zoom. Again, zoom. And now you can see there are pixels or the dots. Now you can clearly see these dots. So if I pick a color here, so let's use color picker. I'm going to right click here and copy colors hexadecimal code, and you can see. So this is the code that so once copied, and I got this code. So 8 means 1000, again 8 means 1000, count the number of digits 0100, C means 1100, and 1 means 0001, and A means 1010. How many bits? 4, 8, 12, 16, 20, and 24 bits. That's what I said. You have 24 bit for one pixel, one single pixel, one single square, this square. Here, let's say a more darker one. So this is closer to back. Right click, copy colors hexadecimal code, and you can see it's 0000, 0011, and 0000, and 0011, and 0000, and 0001. So that is the color. Let's say more lighter color, like this. I'm going to take more lighter colors, which is closer to white. Closer to white. No. Okay, now you can see. Right, this is good. Some more lighter color, which is closer to white. Right click, copy colors hex code. Copy colors hex code, and you can see color is this one. More lighter, the number is high. E means 1110, it's 40, 1110, F means 1111, 2 means 0010, and F means 1111, and D means A, B, C, D. D means C plus 1. Okay, this is how the color is generated. So this is how the pixels are created. And using these pixels, this image is created. Using the images, videos are created. So if you play a video, let's play a video here. Let's go to YouTube. Let's take a video. Okay, let's take a video like this. This animation actually. But when I skip this, you can see it is a video. If I stop the video, you can see a picture. If I stop the video, you can see the picture. If I stop the video, you can see a picture. So if I take a screenshot of this picture and if I just open it using Photoshop or some image editing application, so what will happen? So there you will see. There you can see. Right. Let's zoom this, and you can see the pixels over there. So that's all. In a video, you have pictures. Pictures, you have pixels. So video, you have multiple pictures played back in a sequence. So anyway, now you can see how data representation is done in the computer. And in advanced level, you will learn further and you will learn mechanism to represent the positive numbers and the negative numbers, because you can't send the positive sign, plus sign and minus sign. You can't send it through the wires. So in the A levels, you will learn how to represent these positive numbers and negative numbers. Right, then the other thing is, right, then the other thing is sounds. So how sounds are represented. So now you know how numbers are represented, and you know, so actually you don't know how numbers are represented, but you have an idea, and you know how pictures, videos are represented. And what about sound? Sound is a signal. Here you have sound is a signal. This is an analog signal, and sound representation, basically sound wave is divided to equal time interval. That is called samplers or samples or sampling. The technique is called sampling. You divide the particular analog signal to equal intervals, equal time intervals. And then you take the values. So these values are taken, these values are say quantization levels. You can see 000, 001, 010, likewise. There are 8 quantization levels here in this one, but it can be more. And you can see T, 2T, 3T, likewise, equal time intervals are there. Then this is 4 means 100. Then 6 is 110. Likewise, you represent that in a digital code. And that is how data representation done for the sound waves. Right now, you have more clear idea about all these things. And let's move to our original topic, which is character representation, that is in grade 10 syllabus, right? So please write down the heading, character representation, how to represent letters, characters, numbers, and symbols, which is used in the keyboard. Right, under that, please write, we will focus on representing numbers without signs, right? Numbers without signs. Because with signs, if you represent numbers, there's another mechanism that is called two's complement that you will learn in A levels, right? Not now. That is for the numbers with signs or mathematical numbers. This is like just number symbols, right? Symbols of these numbers. So here we will focus about representing numbers, alphabetic letters, and symbols. In general, you can say in symbols. So that is the focus of this one. Okay, the first method that we use here is called binary coded decimal. And please write down that as well. BCD is a 4-bit representation method introduced by IBM, International Business Machines. They have in their server computers, they were using this 4-bit encoding called BCD. In this system, you can see it's similar to hexadecimal numbers, but only up to 9, right? Using 4 bits, first 9 digits, 0 to 9 digits are represented. So when you represent this BCD number, for an example, if it is 958, 9 is 1001, and 5 is this one, and 8 is this one. Likewise, you write the code. Just look at the chart and write the code. So let's write another number. So 8 is 1000, 6 is 0110, and 4 is 0100. So just write the number by looking at the chart. That's very easy, but because so in original binary, you have to divide the number and get the binary value, which is quite difficult. In original binary, you take the 864 and divide by 2, that is 432. Again, divide by 2. Likewise, you continuously divide the number and write the remainder. So that is the original way of converting decimal to binary. But in this one, it's not converting, right? It's representation. As I said initially, your mother or your father come to represent you in a seminar. Instead of on behalf of you, your father came. So similar to that, on behalf of 9, so 1001 is used. That's all. So let's say 5 is represented by a jackfruit, and 6 is represented by apple, then 56 is jackfruit apple. So that's all. Represent it using something to tell, some other thing to tell, not converting, right? So that's just representing. And because the EBCD, so this BCD has a limitation of 4 bits, because 4 bit can the maximum symbol limit, maximum unique symbol limit is 16. So how it is taken is 2 to the power 4, because you have 4 bits and maximum unique symbol limit is therefore 16. So that is not enough, right? It's not enough to represent characters. It is not enough to represent letters or alphabetical characters. Therefore, so the same people, they introduce another one with 8 bits, which is called EBCD. So the EBCD advantage is it has 8 bits. So how many symbols? So 2 to the power 8, which means 256 unique symbols. That is the advantage of 2 to the power 8 or 256 unique symbols. So that is the advantage of EBCD, extended binary coded decimal interchange code. And this is how this chart actually I have downloaded from the internet and attached to this, because no one will ask you to write the EBCD chart in the examination. It is not possible to remember everything, but you just know how these bits are. For an example, simple A, you can see the first bit is 1, second bit is 0. So the simple A value is 1000 0001, 10000001. On the other hand, you can say 81 in hexadecimal, 81 in hexadecimal. Then 82 is B, 83 is Z. Likewise, EBCD values are changing. And these are the characters represented by EBCD number system. Right, so there's another thing, right? So other than EBCD, so there's another popular mechanism, but that is not, so there is not like EBCD, right? So there is another alternative system. That system is so popular among users. Still we are using this because of the popularity. That is called ASCII, American Standard Code for Information Interchange. We usually like the American standards. So therefore, we have a lot of American standard in Sri Lanka. So you usually like American standard English, and we like American styles, and we like American fashion, and we even like American president, likewise. So at least we like American green card. So all these American products we have preference. No? So if even our leaders attached to America, we really like to select them as our leaders. So it's like that. So just hint, right? Okay. So nothing to talk about the politics. No need to talk about the politics because it's a separate subject. It's not IT, but in generally in living you need that also, right? But not now, in future you will realize and you will understand. But it is always better to look after your own work rather than thinking or criticizing others. Because if you work hard and you can develop your own living style. But if you are lazy, then you have to work according to someone else's living style, which is not going to match with your requirement. Right? That is the nature. So be an entrepreneur, because that is the American style. American style is, so Americans basically they teach their kids, their children to be entrepreneurs. Because the advantage of being an entrepreneur is like when you become an entrepreneur, you can develop your own business and hand it over to your next generation. So next generation is more developed than your generation. That is the idea. Otherwise, if we all searching for government jobs and if you're all searching for a private sector jobs, what will happen? So your kids one day, your next generation, have to do the same. They have to learn, they have to pass the examination, go to universities, obtain degrees, and then just work for someone else. But so as the American stand or American fashion, so they are focusing about entrepreneurship. Yeah, you start your own job, you be your own boss. The advantage is after some time when you retire, you have a business which can be handed over to your next generation, and next generation can hand it over to the next junior generation, and that will be further developed. So if we follow up this style as a country, as a nation, then after 2 or 3 generations, we will become a developed nation. Otherwise, we will remain same as the current status, same in the current status, still underdeveloped and third world country. So that is pathetic. Okay, so that is the separate story. So let's focus back to the American Standard Code for Information Interchange. So we have a lot of relationships with the Americans, and that's why I talk. Okay, then here you have like 7 bits. Unlike the EBCDIC has 8 bits. ASCII has ASCII. This you pronounce as ASCII, right? ASCII. American Standard Code Information Interchange, pronounced as ASCII. ASCII has 7 bits. Therefore, 2 to the power 7 unique symbols. Please write down over there. 2 to the power 7 unique symbols, which is equal to 128 unique symbols, which is enough to represent numbers and letters in the English alphabet. Enough to represent numbers and letters in the English alphabet, right? But not enough to represent the other languages. If you want to write Sinhala, if you want to like Tamil, if you want to like Chinese, Mandarin, or Japanese, so this won't be the ideal solution. But still, what you can do, you can change the font and change the keyboard. By changing the font, virtually you are changing the keyboard. And by doing that, you can write another language. So that is quite hard. Therefore, and there's another version that is called eASCII or extended ASCII. So please write down after that. There's another version, eASCII or extended ASCII. Extended ASCII, and it has 8 bits. eASCII has 8 bits. So 2 to the power 8 unique symbols and 256 characters. That is extended ASCII. And here's the table. The same thing, I have downloaded that from US ASCII, United States American Standard Code for Information Exchange, that's US ASCII version. So these are the symbols. You can see capital A resides here. So you have to read the other way, right? This is the bit 1, bit 2, bit 3, bit 4. And this is bit 5, bit 6, bit 7, the reverse way. So here you have like 1 to 4, 5 to 8 now, but you have 1 to 4 this direction and 5 to 8, 5 to 7 this direction. So A is 10000001. 10000001 is capital A, which is 65 is the ASCII number for the capital letter A. Whereas the simple letter A is here, it is 10000110, which is 64 6. Sorry, this is simple A. A is, yes, 1000, then 011. 10000011. Yes, I guess. A, B, C, D, E, F. Yep. It's changing like this. So wait, I think there's a small mistake over there. Mistake ASCII table. Bit ordering has a mistake, it seems, right? Let's see. I need the large image to show this, right? Still small. Right, you can see here, because ASCII capital letter A is, sorry, where's the letter A? Here you have capital letter A, it is 41. 41 means, in a hexa, 41 means, you can say 1 means 001, that is okay. 4 means 100, okay. 100001, that is A. That is correct, right? 10000001. Yes, 10000041. B is 42. That is 10000011. Sorry, 10000010. That is 10000010. 010 means 010. See, that's why I said this has a wrong numbering, right? Or otherwise you have to read like this, and this bit number in the bit one, this B1 comes last. So let's read like that. So then letter A is, let's write other way. Letter A is 1000001. Again, okay. Letter B is 10011. Here you have to read like this. B7 to B1, right? B7 to B76. मैं पत्ता read करा. එතකොට හරි 10000001 is A. Then 10000010 is B. 10000011 is C. Like, okay. Then what is simple A? 1100001. 110 means 64 plus 32, and this is 97. Right. Right. Then you can see extended ASCII and ASCII, how those are organized. And the last one to discuss today is Unicode. The meaning is unique code. Unique code. That is the last one to discuss today. Unicode or the unique code. Unicode has two versions. One is 16-bit version and the other one is 32-bit version. The first one is 16-bit version and the second one is 32-bit version. 16-bit version means you have like 2 to the power 16 characters, altogether 65,536 characters. And the other hand, you have 32-bit version, which is closer to 4 billion characters. So that is more than enough to give languages to entire universe, I think, entire universe. So because so generally language has few characters. English language 26 letters, it's simple, and 26 capital letters, altogether it's closer to 100 characters with the symbols. But when you have Sinhala language, you have more characters. In English language, you have more characters. Likewise, altogether So if you want to represent multiple languages in a single font, Unicode is a solution. So why? Because if you write in general normal font here, normal font. So I want to write Sinhala now. I have to change the font to Sinhala font like this and write the Sinhala letter. Okay, so even after I write this, okay, Sinhala font C, whatever. Even after I write this, if I select this part, you can see Times New Roman. If I select this part, you can see this 0 KDO 0 KDO, right? But if I select both, you can see it's undefined because you have used two fonts. But Unicode avoid this issue. No need to use multiple fonts to write multiple languages. Instead of that, it focusing on. So if you have hello here, and if I want to write a Sinhala font over there, then what I have to do is I have to change to the Sinhala keyboard and write it like this. But when I select here hello, still font is Skolapotha. If I select here, it's also Skolapotha. If I select all, again the font is Skolapotha. That is Unicode. That is what Unicode or Unicode is. Right, I think now you know about this character representation, the BCD, FZD, ASCII, ASCII, and Unicode, UTF-8. And there are more representation methodologies, but in your syllabus, you have all these things. And in addition to that, you learn how to represent images, that is in grade 11, how to represent sounds. And I said that in future, in the A levels, you'll be learning how to represent the decimal integers, positives, and negatives, as well as how to represent the floating point numbers or the fractional numbers in computer. So that is for A levels. Right? With that, I'm going to stop for today. If you have any question, any doubt, please let me know. You can send it to the WhatsApp group, or you can just comment over there in YouTube. And I think you got something out of the lesson. Please watch the lesson again and again and come to the next class. Then I can ask you various questions to check whether you understood the content. Okay, thank you very much. Bye.